I'm going to explain the concept of LeavePOut cross-validation. It's a technique used to evaluate how well a machine learning model generalizes to unseen data. Imagine you have a dataset. LeavePOut divides it into many folds or splits. Each split leaves out P data points for testing and uses the rest for training the model. We will focus on how many such splits are created. We're given a scenario with a dataset of 10 samples. We're using Sklearn's LeavePOut with P equals 3, which means we're leaving out 3 samples for testing in each split. The task is to determine which statements about the number of folds are true. This sets the scene. We're using a specific tool, LeavePOut, from a machine learning library called Sklearn, which is really useful for creating these specific test train splits. This statement suggests the total number of splits is 120. We'll need to calculate to check this. This suggests that in each split, 7 samples are used for training the model, and 3 are held back for testing. This makes intuitive sense given we started with 10 samples. This suggests each test set created will be unique to avoid repetition. We'll confirm if LeavePOut creates all the possible unique test sets or just a few. This statement gives an upper bound on the number of splits. We need to calculate to verify. This introduces the mathematical formula used to calculate the number of folds. This is the formula for combinations. In words, it's the number of ways to choose P items from a set of N items where order doesn't matter. N means N factorial, N, N1, N2, asterisk 1, the same for P, and NP. This formula gives us the total number of unique ways to choose 3 samples out of 10 samples. This describes the machine learning technique we're using. We have 10 data samples and, in each round of testing, I'll leave out 3 samples, P equals 3. LeavePOut is a cross-validation method in Sklearn that systematically tests all possible combinations of leaving out P data points. The acronym LeavePOut stands for LeavePOut. That's it, pretty straightforward. This section presents the core problem. I want you to figure out what's true about the results from using LeavePOut with this specific setup. Let's dive in. This statement claims that 120 different testing rounds will be created by the LeavePOut method. We'll check this using a formula. This says each of our 120 testing rounds will have 7 data points used for training the machine learning model and 3 used for testing its accuracy. We'll determine if that's correct. This claims there will be 120 distinct groups of 3 data points used for testing. If that's true, it means the LeavePOut method is effectively exploring all possible combinations of leaving out 3 data points. This is a simple statement. The LeavePOut algorithm will generate fewer than 100 testing rounds. We'll see if it's true. We have a dataset containing 10 samples, which is the total number of data points we'll use for our model evaluation. This is a cross-validation technique from Sklearn called LeavePOut. The P equals 3 feet part means we'll leave out 3 samples in each round of testing. LeavePOut is short for LeavePOut. This is the overall description of the problem. We're going to use LeavePOut cross-validation on a dataset with 10 samples. We will remove 3 samples at a time and use remaining samples for training and the removed samples for testing. Each round of testing, a fold, in LeavePOut involves using 7 samples for training and the remaining 3 for testing. We always maintain this division. That is how LeavePOut works. I calculated the total number of different ways I can choose 3 samples out of 10 to leave out, which turns out to be 120 different folds. This is calculated using the binomial coefficient, which is like counting combinations. I'm using Sklearn's LeavePOut cross-validation. I have 10 data samples, and in each round of testing, I'll leave out 3, P equals 3. This is like choosing 3 samples to test from my 10, then training my model on the remaining 7. It's a really thorough way to test. I'll ask you some true, false questions about how many folds LeavePOut will create with these settings. I start with a dataset containing 10 samples, which is my N. In each fold iteration of testing, I set aside a group of 3 samples to test, which represents P. The remaining 7 are used to train my model. I calculate that I'll get a total of 120 different testing folds. This is calculated using the formula 10, 3, asterisk 7, which is read as 10 factorial divided by 3 factorial times 7 factorial. This formula is basically figuring out all the ways to choose 3 samples out of 10. In every fold, I use 7 data samples to train my model and the remaining 3 for testing. I'm asking you about LeavePOut cross-validation. We have a dataset with 10 samples, and we're using. This means we're leaving out 3 samples for testing in each fold. Let's see what you understand about the number of folds this creates. This statement is correct. I calculated the number of folds using the formula for combinations. 10, 3, asterisk 7, equals 120. This formula tells us how many ways we can choose 3 samples out of 10 to be the testing set. That means there are 120 different ways to split the data into training and testing sets. This is also true. Since we're leaving out 3 samples, p equals 3, for testing in each fold, there will be 10 minus 3 equals 7 samples left for training. Yes, because LeavePOut creates every possible combination of leaving out 3 samples, we end up with 120 unique test sets, one for each fold. This is incorrect. We've already determined that there are 120 folds, which is more than 100. We're using LeavePOut, a cross-validation method. I have 10 data points, and in each round, I'm setting aside 3 of them for testing. This, p equals 3 inches means 3 samples are held out in each fold. This is the core problem. I'm using Sklearn's LeavePOut function for cross-validation. This means, I'm testing all possible combinations where 3 samples are set aside from 10 samples. I need to figure out the implications of this setup. I'm working with a dataset that contains exactly 10 samples or data points. This is a crucial piece of information for calculating the number of folds in the LeavePOut cross-validation. This statement proposes that I will have 120 different training, testing sets in my cross-validation. Let's see if this is correct by calculating the number of folds using the binomial coefficient. This statement describes the composition of each fold: 7 samples for training and 3 for testing. Since there are 10 samples in total, 10 minus 3 equals 7, this makes perfect sense. This statement claims that there are 120 unique test sets. This will be true if and only if statement A is true, because LeavePOut creates a test set for each fold. This is simply the opposite of statement A. If statement A is true, this is false. If statement A is false, then this could be true.